Welcome all for the Database Management System Session 9 of second semester BCA affiliated to Kuvempu University. Dear students, today we will be going on with the topic called as application architecture, or specifically today we will be learning one of the important architecture of our database management system, that is called as a three-schema architecture. So this is one of the important question for even for your exams, as well as this is one of the fundamental thing which a particular fresher should know when he is going to learn a database management system there. So now, before going on to our today's topics, let us have a short recap of our previous session. So students, I think you all remember in our previous session number 8, we have learnt about the structure or the environment of our database system there. So in that, I think you remember we have learned different things there. So to tell some of the keywords there, we have learnt about how the particular different users are going to work in our database environment. For example, what is the task of a DBA? What is the paracentric users are going to do? How the end users are going to perform there? So if you have the different DDL commands, if you have the different privilege commands there, how the DDL compiler is going to execute there? Even what do we mean by a stored manager? And what is the task he is going to perform there? Where the data has been stored? Everything we have learned there. So with that information, in today's session, I think let's start learning about a concept called as what application architecture, or to be specifically, we'll learn very important architecture called as a three-schema architecture there. So the session outcomes will be the student will be able to understand the application architecture, that is the three-schema architecture. So before starting on to our today's lecture on our three-schema architecture, I think you all remember the term called as a schema, isn't it? So you have learned what do you mean by data, you have learned what do you mean by database, you have learned what do you mean by database management system, and even as an example you have learned a university database there. In that you have seen the different schemas, you have seen the different tables there, and even if you have seen the different attributes working with your tables there. So schema, what actually it is, I know everybody is aware of that. Schema, it actually defines the structure of your database, isn't it, or the structure of a table, how it is being designed. So that is been focused on your schema. So now if I'll take the entire application architecture, the entire schema, it is been divided into three different levels there. See, the entire architecture of our database system, it is been proposed with the help of, it has been proposed to achieve and visualize all the characteristics which a database management system has to have. So for achieving all those things, the entire architecture, it has been visualized in a three-level schema architecture. So the following are the three different schemas which are going to come in your DBMS architecture there. So the first one is called as internal level, second one is conceptual level, and third one is called as external level. So remember all these three names there. I'll tell you again, the schema in DBMS can be described at how many levels? Yes, it is in three levels. The first level is what? Internal schema, and this internal schema has an internal schema itself. The conceptual schema, it works on the conceptual level of your schema, and the external level, it includes a number of external schemas as well as various user views. See, all the three levels, that is your internal level or a conceptual level or an external level, the information of all these three schemas has to be stored somewhere, isn't it? So remember, dear students, the information about all three schemas is being stored in something called as what? System catalog. So don't forget this one, make a note of that. That is, all the information related to all the different levels of schemas will be stored where? Yes, it is stored in what? System catalog. So now we understood that we have three levels of schema. Those are internal, conceptual, and external. And entire information about that all the three schemas which is going to be stored where? It is in your system catalog. Now let us see the architecture diagram of this three schema. See, at the low level you can see here you have what? Stored databases there. What you have your stored databases. So above that we have what? Your internal schemas, and above that we have what? Your conceptual schema, and above that we have your external views there. You can see there you can have multiple external views, and all the views are coming from your different end users there. Okay, so next in the internal schema, it is going to describe the internal concept or the internal design of your table or a database or a schema there. So the next level is your what? Conceptual schema. This is also called as what? Conceptual mapping, or it can also be, we perform an operation called as internal mapping there. So between the external level and your conceptual level, we have a mapping called as external mapping or a conceptual mapping. And you can find out that it is a two-way as well as this is a two-way there. Here the data will be stored there. I think you got an idea about how diagrammatically you can write the three schema architecture. Below you have your stored databases. Above that you have your internal level, that is your internal schema. Above that you have your conceptual level, that is your conceptual schema, which are singly defined. And above that you have your external level, which is called as your external schema there, where you have not a single view but you have your what? Multiple external views, all coming from your different end users. So you are clear about this particular diagram. Remember, you need to write this diagram for your exams also. Okay. Now in detail, let us try to understand what this internal, conceptual and external schema is going to have in our architecture there. Okay. So now let's start with our first one, that is your internal level. The name itself is telling. It is describing everything about the internal components there. So that is, see, in our database architecture, the main task is to store our data, isn't it? So once the data is been stored, the next thing is to allow to perform various database operation. It may be working with your database, for example, retrieval of your data, again inserting of your new data or updating of your data, isn't it? So there you are performing some input and output operation, isn't it? So the internal schema, it is focusing on these things there. That is what we have written there. The internal schema, it specifies the complete details of your storage and the access path for your databases. I think you're familiar about the storage, how whether it is stored in a secondary storage or in a magnetic disk, or what is the way the data will be stored, whether it is a file system or something else there. So those details will be stored as a part of what your internal schema there. Okay, now we found that data has been stored there. We need to access that, isn't it? So for accessing that, we have different access paths. You will learn the different access paths in your unit number 3 here. So what type of access path is being used by your database management system? Those details will be pertaining to, those details will be stored in your which schema level? Yes, it is in your internal schema level. Next, see, in our internal schema, the file organization are different there. That is the way the data is been stored. It is multiply. We have different techniques for that. So the file organization on the disk should be decided whether the data will be stored in which way. That is whether you are applying your hashing file system, hashing methodology, or you are applying your indexing techniques there for storing your data, or you are using some other random technique for storing your data. So those all information also will be specified where? Yes, in our internal schema there. Also, the process of arriving at a good physical database scheme is called as your physical database design there. So the physical database design approach, or a method or a process which has to be done, it is been done in your which level? Yes, in your internal schema. I think you are clear about your internal schema, isn't it? So here we are going to get the complete details about the storage, what is the file organization you are using, and what is the access path you are using. So this is very important for getting a good database to be created there. Okay. So I think you are clear about the first one, that is what your internal schema. Now let us move on to the second level or the second schema, that is called as what? Conceptual schema. See, in the internal schema, you have learnt about the storage, the access path and the file system which have to be deployed, isn't it? Now internally, once they are done, we have to enter into our conceptual concept there, the conceptual way there. That is the conceptual schema, or you can also call by a term called as a logical schema. See, remember the term, the conceptual schema is also called as what schema? Logical schema. So what it is going to do is, it is going to describe the entire structure of your database. ನಿಮ್ಮ ಡೇಟಾಬೇಸು ಹೇಗಿದೆ, ಅದರಲ್ಲಿ ಏನೇನು ಎಂಟಿಟೀಸ್ ಇದೆ, ಅದರಲ್ಲಿ ನೀವು ಯೂಸ್ ಮಾಡ್ತಿರೋ ಬೇರೆ ಬೇರೆ ಆಟ್ರಿಬ್ಯೂಟ್ಸ್ ಯಾವ್ದು, ಯಾವ ಆಟ್ರಿಬ್ಯೂಟ್ಸಿಗೆ ಏನೇನು ಡೇಟಾ ಟೈಪ್ಸ್ ಇದ್ದಾವೆ, ಮತ್ತು ಒಂದು ಡೇಟಾ ಮತ್ತು ಇನ್ನೊಂದು ಡೇಟಾ, ಅಥವಾ ಒಂದು ಆಟ್ರಿಬ್ಯೂಟ್ ಮತ್ತು ಇನ್ನೊಂದು ಆಟ್ರಿಬ್ಯೂಟ್, ಅಥವಾ ಒಂದು ಎಂಟಿಟಿ ಮತ್ತು ಇನ್ನೊಂದು ಎಂಟಿಟಿ ಮಧ್ಯದಲ್ಲಿ ಡು ಯು ಹ್ಯಾವ್ ಎನಿ ರಿಲೇಷನ್ಶಿಪ್. ಮತ್ತು ಈಗ ಡೇಟಾಬೇಸ್ ಅಂದರೆ ಯು ಹ್ಯಾವ್ ಮಲ್ಟಿಪಲ್ ಎಂಟಿಟೀಸ್, ಮಲ್ಟಿಪಲ್ ಟೇಬಲ್ಸ್ ವಿಲ್ ಬಿ ದೇರ್. ಆ ಡೇಟಾಬೇಸ್ ಮಧ್ಯದಲ್ಲಿ ವಾಟ್ ಆಲ್ ದ ಡಿಫ್ರೆಂಟ್ ಆಪರೇಷನ್ ಯೂಸರ್ ಕ್ಯಾನ್ ಪರ್ಫಾರ್ಮ್. If it is a relational database model, whether you are performing this, select there. whether you are performing any joins there, or you are performing any project operation. So those all descriptions will be provided by your what logical schema or your conceptual schema. Also you will be posting lot of constraints, isn't it? You have learned, you will be learning in the next slide there. So what do we mean by constraints? Primary key constraints, foreign key constraints. So even that will be specified in your conceptual schema. Understood? So that's what we are telling here. The conceptual schema hides the details of what? Physical storage structures and concentrates on what? Describing the entities, the tables, the data types you are using, the relationship which are coming there, the user operations, as well as the constraints which are being posed there. Understood? So this is the main essence of your conceptual schema. See, a representational data model, normally it is the best suited to describe the conceptual schema when a database is implemented. So you have to remember there, when you are implementing your database, even you need to take care of what is the data model you are going to use there. I think in our initial sessions you have learnt about different data models, isn't it? So among them we have a model called as representation model. This representation model, this is the best way we can describe our conceptual schema when you go for implementing your databases there. Okay, so the process of arriving at a good conceptual schema is termed by a name called as what? Conceptual database design. I don't know whether it will be asked in your exam, but remember that there is something called as conceptual database design, and this is been achieved in our which schema level? That is your conceptual schema level. So I think you are understood about your conceptual schema. Yes, in internal schema, how the storage is been done, what is your access path, file system being used, the basic level. Now we are entering into the logical aspect of your database. That is, in our conceptual schema, we are more focused upon the structure of your database, what it is composed of, how it is going to work, how it is been interlinked there. All these things will be done in your what? Conceptual schema. Okay. See, we have some examples for your conceptual schema. Just now we understood that conceptual schema is going to work on what? Structure of your database, isn't it? So I have some examples for your databases there. You can find out there are 7 different conceptual schema examples there. That is, first conceptual schema is been termed as what? Example is students. Second is faculty, courses, rooms, enrolled, teachers and meeting. I think you can find out this is something related to your university database, isn't it? See, when you enter students, faculties, courses, rooms and all, these are all are nothing but your tables. Or you can tell these are all nothing but your what? Entities. That is what we have learnt in the previous slide. That is, conceptual schema, it focuses on understanding the internal structure of the database. Specifically, it is concentrating on the different entities you are having. In the example, you have 7 entities there, student, faculty and all. Next, I said that there it is, the focus is on the data types being used, relationships being used, constraints being followed, isn't it? See, for the entity student, you have SID, SName, login, age and GPA, which are the attributes of your what? Students. And for SID, that is your student ID, you have as a data type the string type. For the student name, again you have a data type called as string only. When you consider the age, you have the data type as what? Integer. And for your GPA, that is your grades, you have a data type as called as real or a floating value. See, this describes your database. This is the conceptual thing which will be focused in your second level, that is your conceptual schema. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಸ್ಕೀಮಾ ಅಂದರೆ ನಾವು ಯಾವ್ದ್ರ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದ್ದೀವಿ ಅಂತೇಳಿ. ಈಗ ನೋಡಿ, ಇನ್ನೊಂದು ಎಂಟಿಟಿ ತೊಗೊಳ್ಳೋಣ, ಅದ್ರ ಹೆಸರು ಏನು ಅಂದರೆ ಫ್ಯಾಕಲ್ಟಿ. ಓಕೆ, ಫ್ಯಾಕಲ್ಟಿ ಅನ್ನೋದು ಎಂಟಿಟಿ. ಅದರಲ್ಲಿ FID ಅಂದರೆ ಏನು? ಫ್ಯಾಕಲ್ಟಿ ID ಅನ್ನೋದೇನು? ಅದರ ಆಟ್ರಿಬ್ಯೂಟು. ಅದನ್ನು ಸ್ಟೋರ್ ಮಾಡೋದಕ್ಕೆ ನಾನು ಯೂಸ್ ಮಾಡ್ತಿರೋ ಡೇಟಾ ಟೈಪ್ ಯಾವುದು? ಸ್ಟ್ರಿಂಗ್. ಸಿ, ನಮ್ಮ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಯಾವ್ದ್ರ ಮೇಲಿದೆ? ಎಂಟಿಟಿ ಮೇಲಿದೆ, ಮತ್ತು ಅದರದ್ದು ಡೇಟಾ ಟೈಪ್ಸ್ ಮೇಲಿದೆ. ಅದೇ ರೀತಿ ಫ್ಯಾಕಲ್ಟಿ ನೇಮು ಸ್ಟ್ರಿಂಗಲ್ಲಿ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. ಫ್ಯಾಕಲ್ಟಿಯ ಸ್ಯಾಲ್ರಿ ರಿಯಲ್ ವ್ಯಾಲ್ಯೂ, ಎಷ್ಟು ಸಾವಿರ ದುಡ್ಡು ಬರ್ತಾ ಇದೆ ಅಂತೇಳಿ, isn't it? So in the same way you have courses. For courses the attributes are CID, CName and credits there. For the room you have the attributes called as R number and room number string, address string, capacity integer, that is how many students can be accommodated in a room, whether it is 30 students or 60 students. In the same way we have another entity called as what? Enrolled. ಅದರಲ್ಲಿ ಸ್ಟೂಡೆಂಟ್ ID, ಎಲ್ಲಿ ಯಾವ ಸ್ಟೂಡೆಂಟ್ ಎನ್ರೋಲ್ ಆಗಿದ್ದಾರೆ ಅಂತೇಳಿ, CID ಯಾವ ಕೋರ್ಸಿಗೆ ಎನ್ರೋಲ್ ಆಗಿದ್ದಾರೆ ಅಂತೇಳಿ, ಗ್ರೇಡ್ ಅಂತೇಳಿ. ಸಿ, ಈ ಫಸ್ಟು, ಸೆಕೆಂಡು, ಥರ್ಡ್, ಫೋರ್ತಲ್ಲಿ ನಿಮಗೆ ಎಂಟಿಟೀಸು, ಆಟ್ರಿಬ್ಯೂಟ್ಸು ಮತ್ತು ನಿಮ್ಮ ಡೇಟಾ ಟೈಪ್ಸ್ ಬಗ್ಗೆ ಗೊತ್ತಾಯಿತು. ಈ ಎನ್ರೋಲ್ ಟೇಬಲ್ನ ನೀವು ರೆಫರ್ ಮಾಡಿದ್ರೆ ಎಂಟಿಟಿನ, ಯು ಕ್ಯಾನ್ ಸಿ ದೇರ್ SID, It's an attribute which is coming from what? Student table. And CID is an attribute which is coming from your course table. ಸೊ SID ಮತ್ತು CID ಎನ್ರೋಲ್ ಟೇಬಲಿಂದ ಅಲ್ಲ, ಆದರೆ ಅಲ್ಲಿ ಯೂಸ್ ಆಗ್ತಾ ಇದೆ ಅಲ್ವಾ. ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಯುವರ್ ರಿಲೇಷನ್ಶಿಪ್ಸ್. ಒಂದು ಟೇಬಲ್ಲು, ಒಂದು ಎಂಟಿಟಿ ಇನ್ನೊಂದು ಎಂಟಿಟಿ ಮಧ್ಯದಲ್ಲಿ ಒಂದು ರಿಲೇಷನ್ಶಿಪ್ ಇದೆ ಅಂಥೇಳಿ. ಸೊ ಇದು ಕೂಡ ನಾವು ಫೋಕಸ್ ಮಾಡೋದು ಎಲ್ಲಿ? ನಮ್ಮ ಯಾವ ಸ್ಕೀಮಾ ಲೆವೆಲಲ್ಲಿ? ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಲೆವೆಲಲ್ಲಿ. ಅಂಡರ್ಸ್ಟುಡ್? ಗೊತ್ತಾಗ್ತಿದೆ ಅಲ್ವಾ? ವಿತ್ ಥಿಯರಿ ಆ್ಯಂಡ್ ಎಕ್ಸಾಂಪಲ್ ಗೊತ್ತಾಗ್ತಿದೆ ಅಲ್ವಾ? ಸೊ ಇನ್ ದ ಸೇಮ್ ವೇ ಟೀಚರ್ಸ್ ಮತ್ತು ಮೀಟಿಂಗ್ ಇನ್. So this example depicts the conceptual schema. So I think, dear students, now you understood about your internal schema and you have also understood about a conceptual schema. ಮತ್ತೊಂದು ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಸ್ಕೀಮಾಗೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತೊಗೊಂಡ್ಬಿಟ್ಟು ಅದರಲ್ಲಿ ಎಂಟಿಟಿ, ಡೇಟಾ ಟೈಪ್, ರಿಲೇಷನ್, ಕನ್ಸ್ಟೆಂಟ್ಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಿದ್ವಿ. ಈಗ ನಮ್ಮ ಮೂರನೇದು, ಓಕೆ, ಆ ಮೂರನೇ ಲೆವೆಲ್ ಯಾವುದು? ಎಸ್, ಯು ಕ್ಯಾನ್ ಟೆಲ್. ಎಸ್, ಇಟ್ ಈಸ್ ವಾಟ್? ಎಕ್ಸ್ಟರ್ನಲ್ ಸ್ಕೀಮಾ. ಅದರಲ್ಲಿ ಏನಿದೆ ಅನ್ನೋದನ್ನು ನೋಡ್ತಾ ಹೋಗೋಣಂತೆ. ಸಿ, ಫಸ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಏನು ಅಂದರೆ ಎಕ್ಸ್ಟರ್ನಲ್ ಸ್ಕೀಮಾ ಮತ್ತು ನಮ್ಮ ಇನ್ನೂ ಎರಡು ಸ್ಕೀಮಾದಲ್ಲಿರೋ ಡಿಫ್ರೆನ್ಸಸ್ನ ನೋಡ್ಕೊಳ್ತಾ ಹೋಗೋಣಂತೆ. ಅದಕ್ಕಿಂತ ಮುಂಚೆ ಲೆಟ್ ಮಿ ಟೆಲ್ ಯು ದ ಫಸ್ಟ್ ಥಿಂಗ್. ದ ಎಕ್ಸ್ಟರ್ನಲ್ ಸ್ಕೀಮಾ, ಇಟ್ ವಿಲ್ ಅಲೋ ದ ಡೇಟಾ ಆಕ್ಸೆಸ್ ಟು ಬಿ ಕಸ್ಟಮೈಸ್ಡ್ ಅಟ್ ದ ಲೆವೆಲ್ ಆಫ್ ಇಂಡಿವಿಜುವಲ್ ಯೂಸರ್ಸ್. At the level of what? Individual users, and hide the rest of the details from the user. ಅಂದರೆ you will get a high level of abstraction in your external schema. ಅಬ್ಸ್ಟ್ರಾಕ್ಷನ್ ಅಂದರೆ ಗೊತ್ತಿದೆ ಅಲ್ವಾ? ಓನ್ಲಿ ದ ನೀಡೆಡ್ ಇನ್ಫಾರ್ಮೇಷನ್ ವಿಲ್ ಬಿ ಸ್ಪೆಸಿಫೈಡ್. ಸಿ, ಎಕ್ಸ್ಟರ್ನಲ್ ಸ್ಕೀಮಾದಲ್ಲಿ ನಿಮಗೆ ಡೇಟಾ ಆಕ್ಸೆಸ್ ಮಾಡೋದಕ್ಕೆ ಸಿಂಗಲ್ ಯೂಸರ್ ಲೆವೆಲಲ್ಲಿ ಸಿಗುತ್ತೆ, ಮತ್ತು ರಿಮೈನಿಂಗ್ ಒಳಗೆ ಇಂಟರ್ನಲ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟೀಸ್ನೆಲ್ಲ ಹೈಡ್ ಮಾಡಿರ್ತೀವಿ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಸೊ ಎರಡನೇದೇನು ಅಂದರೆ ಎನಿ ಡೇಟಾಬೇಸ್, ಅಂದರೆ ನೀವು ಯಾವುದೇ ಡೇಟಾಬೇಸ್ ಯೂಸ್ ಮಾಡಲಿ, ಹ್ಯಾಸ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಒನ್ ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಸ್ಕೀಮಾ ಆ್ಯಂಡ್ ಒನ್ ಫಿಸಿಕಲ್ ಸ್ಕೀಮಾ. ಈಗ ನೀವು ಸ್ಟೂಡೆಂಟ್ ಡೇಟಾಬೇಸ್ ತೊಗೊಳ್ಳಿ, ಎಂಪ್ಲಾಯ್ ಡೇಟಾಬೇಸ್ ತೊಗೊಳ್ಳಿ, ಎನಿ ಡೇಟಾಬೇಸ್ ಯು ಟೇಕ್ ದೇರ್, ಅದರಲ್ಲಿ ನಾನು 3 ಸ್ಕೀಮಾ ಆರ್ಕಿಟೆಕ್ಚರಾಗಿ ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ದಟ್ ಯಾವುದೇ ಡೇಟಾಬೇಸ್ ನೀವು ತೊಗೊಂಡ್ರು ನಿಮಗೆ ಇಲ್ಲಿ ಇಂಟರ್ನಲ್ ಸ್ಕೀಮಾ ಅಂದರೆ ನಿಮ್ಮ ಫಿಸಿಕಲ್ ಸ್ಕೀಮಾ ಮತ್ತು ನಿಮ್ಮ ಲಾಜಿಕಲ್ ಸ್ಕೀಮಾ ಇದೇನಿರುತ್ತಲ್ವಾ, ಇದು ಎರಡೂ ಕೂಡ ಒಂದೇ ಒಂದು ವ್ಯೂ ಸಿಗುತ್ತೆ. ಆದರೆ ನಿಮ್ಮ ಈ ಎಕ್ಸ್ಟರ್ನಲ್ ಸ್ಕೀಮಾದು ಯು ಕ್ಯಾನ್ ಹ್ಯಾವ್ ವ್ಯೂಸ್ ಟು ಸಪೋರ್ಟ್ ಡಿಫ್ರೆಂಟ್ ಯೂಸರ್ಸ್. ಓಕೆ, remember this. Any database has exactly one conceptual schema and one physical schema, but may have many external schemas in use to support what? Different users. This is one of your interview question. Okay, interviews alli normally ಕೇಳಬಹುದು. 3 ಸ್ಕೀಮಾ ಆರ್ಕಿಟೆಕ್ಚರ್ ಡೇಟಾಬೇಸ್ ತೊಗೊಂಡ್ರೆ ಕಾನ್ಸೆಪ್ಚುಯಲ್ ವ್ಯೂಸ್ ಎಷ್ಟಿರುತ್ತೆ, ಎಷ್ಟು ಯೂಸರ್ಸ್ ಇರ್ತಾರೆ ಅಷ್ಟು ವ್ಯೂಸ್ ಬರುತ್ತೆ. ಫಿಸಿಕಲ್ ಸ್ಕೀಮಾ ಮತ್ತು ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಸ್ಕೀಮಾ ಮಾತ್ರ ಏನಿರುತ್ತೆ? ಒಂದೇ ಇರುತ್ತೆ. Okay, understood? Very important thing in your external schema. Okay, we'll move on. So next is, each external schema consists of collection of one or more number of views or table. See, ನಮ್ಮ ಎಕ್ಸ್ಟರ್ನಲ್ ಸ್ಕೀಮಾದಲ್ಲಿ ನೀವು ಯಾವುದೇ ತೊಗೊಳ್ಳಿ, ಅದರಲ್ಲಿ ಮೋರ್ ದೆನ್ ಒನ್ ವ್ಯೂಸ್ ಇರುತ್ತೆ ಅಥವಾ ಮೋರ್ ದೆನ್ ಒನ್ ಟೇಬಲ್ಸ್ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಸ್ಕೀಮಾ ಈಸ್ ಗೈಡೆಡ್ ಬೈ ಯುವರ್ ಎಂಡ್ ಯೂಸರ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಕೋರ್ಸ್ ಇನ್ಫೋ, ನಿಮಗೆ ಕೋರ್ಸ್ ಇನ್ಫೋ ಬೇಕು ಅಂದರೆ ಕೋರ್ಸ್ ಐಡಿನೂ ಬೇಕು, ನಿಮ್ಮ ಫಸ್ಟ್ ನೇಮು ಬೇಕು, ಮತ್ತು ನಿಮ್ಮ SIDನೂ ಬೇಕಲ್ವಾ? ಅದೆಲ್ಲದು isn't it? That is what we are telling. It consists of one or more tables, or it consists of one or more views. I think you are clear about this. So finally you understood about what is an external schema. So now we'll have some more information about this architecture there. See, ಈ 3 schema architectures are only description of your data. ನಿಮ್ಮ ಡೇಟಾ ಸ್ಟೋರೇಜ್ ಲೆವೆಲಲ್ಲಿ ಹೇಗಿರುತ್ತೆ, ನಿಮ್ಮ ಡೇಟಾ ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಲೆವೆಲಲ್ಲಿ ಹೇಗಿರುತ್ತೆ, ಮತ್ತು ನಿಮ್ಮ ಡೇಟಾ ಥರ್ಡ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಲೆವೆಲಲ್ಲಿ ಹೇಗಿರುತ್ತೆ ಅಂತೇಳಿ. ದ ಸ್ಟೋರ್ ಡೇಟಾ ದಟ್ ಆ್ಯಕ್ಚುಲಿ ಎಕ್ಸಿಸ್ಟ್ ಈಸ್ ಅಟ್ ಯುವರ್ ಫಿಸಿಕಲ್ ಲೆವೆಲ್. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್, ಸೊ DBMS ಏನು ಮಾಡಬೇಕು ಅಂದರೆ ಈ ಒಂದು ಲೆವೆಲಿಂದ ಇನ್ನೊಂದು ಲೆವೆಲಿಗೆ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಮೂವ್ ಫ್ರಮ್ ದ ಇಂಟರ್ನಲ್ ಟು ಯುವರ್ ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಟು ಎಕ್ಸ್ಟರ್ನಲಿಗೆ ಹೋಗಬೇಕಲ್ವಾ. ಸೊ ಇದು ಮೂವ್ ಮಾಡೋದಕ್ಕೆ DBMS ಮಸ್ಟ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಎ ರಿಕ್ವೆಸ್ಟ್ ಸ್ಪೆಸಿಫೈಡ್ ಆನ್ ಅನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಸ್ಕೀಮಾ. ಟಾಪ್ ಲೆವೆಲ್, ಯೂಸರ್ ಲೆವೆಲಲ್ಲಿ ಸಿಗುತ್ತಲ್ಲ ಮೇಲ್ಗಡೆ ನನಗೆ ಟಾಪ್ ಲೆವೆಲಲ್ಲಿ. ಸೊ ರಿಕ್ವೆಸ್ಟ್ ಸ್ಪೆಸಿಫೈಡ್ ಆನ್ ಅನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಸ್ಕೀಮಾ ಇನ್ ಟು ಯುವರ್ ರಿಕ್ವೆಸ್ಟ್ ಅಗೇನ್ಸ್ಟ್ ದ ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಸ್ಕೀಮಾ, and then into your request on the internal schema for processing over the store database. ಅರ್ಥ ಆಯ್ತಾ? ಒಂದು ಡೇಟಾಬೇಸ್ ರೆಡಿ ಇದೆ, ಒಂದು ಯೂಸರಿನ ರಿಕ್ವೆಸ್ಟ್ ಬಂದಿದೆ ಅಂದರೆ ಅದು ಫಸ್ಟು ನಿಮ್ಮ ಎಕ್ಸ್ಟರ್ನಲ್ ಸ್ಕೀಮಾ ಯೂಸರ್ ಲೆವೆಲಿಂದ ನಿಮ್ಮ ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಲೆವೆಲಿಗೆ ಬಂದು ಅಲ್ಲಿಂದ ಇಂಟರ್ನಲ್ ಲೆವೆಲಿಗೆ ಬಂದುಬಿಟ್ಟು ಕಂಪ್ಲೀಟ್ ಪ್ರೊಸೆಸಿಂಗ್ ಆಗುತ್ತದು. ರಿಮೆಂಬರ್ ದಿಸ್ ಫ್ಲೋ. ಸೊ ಈ ಪ್ರೋಸೆಸ್ ನಡೆಯುತ್ತಲ್ಲ, ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ನಡೆಯುತ್ತಲ್ಲ, ನಿಮ್ಮ ರಿಕ್ವೆಸ್ಟಿಂದ ಒಂದರಿಂದ ನಡೀತಾ ಹೋಗುತ್ತಲ್ವಾ, ಇದನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದರೆ ವಿ ಕಾಲ್ ಇಟ್ ಆ್ಯಸ್ ವಾಟ್? ಮ್ಯಾಪಿಂಗ್. ನಾ ಡಯಾಗ್ರಾಮ್ ಹೇಳಿದ್ನಲ್ವ ನಿಮಗೆ, ಇಂಟರ್ನಲ್ ಮ್ಯಾಪಿಂಗ್ಸ್ ಮತ್ತು ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಪಿಂಗ್ಸ್ ನಡೆಯುತ್ತೆ ಅಂಥೇಳಿ. ಸಿ, ದ ಪ್ರೋಸೆಸ್ ಆಫ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮಿಂಗ್ ದ ರಿಕ್ವೆಸ್ಟ್ ಆ್ಯಂಡ್ ರಿಸಲ್ಟ್ಸ್ The process of what? Transforming the request ಮತ್ತು ರಿಸಲ್ಟ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಲೆವೆಲ್ಸ್. ಈ ಒಂದರಿಂದ ಒಂದು ಲೆವೆಲಿಗೆ ನಾವು ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಮಾಡ್ತೀವಲ್ವಾ, ಇದನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ? ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ವಾಟ್? ಮ್ಯಾಪಿಂಗ್ಸ್. ಸೊ ರಿಮೆಂಬರ್ ದಿಸ್ ಒನ್, ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಮ್ಯಾಪಿಂಗ್. So dear students, so I think finally you are clear about this entire diagram there. So you have your stored databases. ಅದರ ಮೇಲೆ ನಿಮ್ಮ ಡೇಟಾಬೇಸಿನ ಸ್ಟ್ರಕ್ಚರ್ ಹೇಗಿದೆ, ಫೈಲ್ ಆರ್ಗನೈಸೇಷನ್ ಹೇಗಿದೆ, ನೀವು ಯೂಸ್ ಮಾಡ್ತೀರಾ ಇಂಡೆಕ್ಸಿಂಗ, ಹ್ಯಾಶಿಂಗ ಅಥವಾ ಆಕ್ಸೆಸ್ ಪಾತ್ಸ್ ಏನೇನು ಯೂಸ್ ಮಾಡ್ತೀರಾ ಅನ್ನೋದು ನಿಮ್ಮ ಇಂಟರ್ನಲ್ ಲೆವೆಲಲ್ಲಿ ಗೊತ್ತಾಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ನಿಮ್ಮ ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಲೆವೆಲಲ್ಲಿ ಏನು ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ? ನಿಮ್ಮ ಸ್ಕೀಮದಲ್ಲಿ ಈ ಸ್ಟ್ರಕ್ಚರ್, ಡೇಟಾಬೇಸಿನ ಸ್ಟ್ರಕ್ಚರ್ ಹೇಗಿದೆ, ಅಂದರೆ ಏನೇನು ಎಂಟಿಟೀಸ್ ಬರುತ್ತೆ, ಆಟ್ರಿಬ್ಯೂಟ್ಸ್ ಏನಿರುತ್ತೆ, ಡೇಟಾ ಟೈಪ್ ಏನಿದೆ, ರಿಲೇಷನ್ಶಿಪ್ಸ್ ಏನಿದೆ, ಕನ್ಸ್ಟ್ರೆಂಟ್ಸ್ ಏನಿದೆ, ಓವರ್ ಆಲ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಯುವರ್ ಡೇಟಾಬೇಸ್ ವಿಲ್ ಬಿ ಒಬ್ಟೈನ್ಡ್ ಇನ್ ಯುವರ್ ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಸ್ಕೀಮಾ. ಅದಷ್ಟು ಸಿಕ್ಕಿದ ಮೇಲೆ ಅದನ್ನು ಆಕ್ಸೆಸ್ ಮಾಡೋದಕ್ಕೆ ಎಂಡ್ ಯೂಸರ್ ಲೆವೆಲ್ ಅಥವಾ ಎಕ್ಸ್ಟರ್ನಲ್ ವ್ಯೂ ಅನ್ನೋದು ನಿಮ್ಮ ಮೇಲ್ಗಡೆ ನಡೆಯುತ್ತೆ. ಸೊ ಈಗ ಯಾವುದೇ ಒಂದು ರಿಕ್ವೆಸ್ಟ್ ಬಂತು ಅಂದರೆ ಎಂಡ್ ಯೂಸರ್ ವ್ಯೂವಿಂದ ಅದು ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಲೆವೆಲಿಗೆ ಮ್ಯಾಪ್ ಆಗಬೇಕು, ಅಲ್ಲಿಂದ ಇಂಟರ್ನಲ್ ಲೆವೆಲಿಗೆ ಮ್ಯಾಪಿಂಗ್ ಆಗಿಬಿಟ್ಟು ಎಂಟೈರ್ ಪ್ರೊಸೆಸ್ ನಡೆಯುತ್ತೆ. ಸೊ ಒಂದು ಲೆವೆಲಿಂದ ಇನ್ನೊಂದು ಲೆವೆಲಿಗೆ ನಿಮ್ಮ ರಿಕ್ವೆಸ್ಟ್ ಮತ್ತು ನಿಮ್ಮ ರಿಪ್ಲೈ ನಡೆಯುತ್ತಲ್ವಾ, ಆ ಒಂದು ಕನ್ವರ್ಷನಿಗೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ವಾಟ್? ಎಸ್, ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ವಾಟ್? ಮ್ಯಾಪಿಂಗ್. So I think dear students, now you are all very clear about your three-schema architecture there. So the session summary is the student will be able to understand the application architecture, in specifically the three-schema architecture. So dear students, for further references you can refer these two books there. One is titled Fundamentals of Database System, it's 5th edition by AW Publication, and the author of the book is Navate. And you can refer another book by title Database System Concepts, authored by Korth and Sudarshan. It's the 4th edition of your McGraw-Hill.